dependent variable. Go to right and put an arrow from the y variable to the f of x. Dependent variable. So y becomes f of x. Okay? Y becomes f of x. Because y is a function of x. And let me explain. Just go and write that for now. So on that note guide, I want you to write in some things because you're going to keep that. Notice right here, f is a function name. Valdez, Gonzalez, stay with me. The parentheses here, notice on your handout, does not mean multiplication. The x, though, is where you put in the x value. Notice how this is what you grew up with Math 1 and pre-algebra. The only thing now, Mata, is that we're replacing y with f of x because y depends on x. Think of the warm-up. Y was whatever we got for y depended on what x values I plugged in here for warm-up. I plugged in -2, -3, and -8. And y depended on what x was. So look at how do we speak it? Look at underneath. How do you say this? Well, you learned in pre-algebra. Y equals 2x plus 5. That's how you say it. How do you say that, though? Look at this. F of x equals 2x plus 5. These mean the same thing. This is just a higher level of notation for higher math classes and higher math exploration and study. In other words, when you get into higher math classes in college, you're going to be seeing equations that look like this in function form, even though it means the same thing as this. So whenever you see f of x, it's just a fancy schmancy way of saying y. So this is how you speak them. Look at the next row. Ordered pairs. You know when we graph? X, y for standard notation. But here, it's x and then whatever f of x is, whatever the function is at that input value. Let's go down more. How about when you graph? Look at the y-axis. The y-axis is no longer the y-axis. We call it the f of x axis. Notice that. See? It's f of x instead of y. What I'm trying to get you to see is that y and f of x mean the same thing. Okay? They mean the same thing. Now watch this funny video. Watch this. Go back to your note guide, actually your note paper. So put that to the side, note paper now. When we're dealing with functions, you want to think of a machine like this. Going into the machine are inputs, okay, like numbers, like say 2, and on the outputs are numbers also, like say 3. So if something goes in, these are your x values, and something comes out, which is your f of x values, your y values. F of x means y now. Let me give you an example now. So you have your function notation. We wrote f of x and those two equations. Go to write example 1 now on your notes. Go to write change to function form and evaluate at the input of -8. So we're going to write y equals 2x plus 2. This is example 1. I'm only going to give you 2 examples and we're going to be done. This is example 1. Change to function form and evaluate at the input of -8. How does this go? Thank you. Just 2 examples. Good, Bill does. Dig. Just 2. This one and one more. Change to function form and evaluate at the input of -8. Okay, first things first. If we're going to change to function form, I change the dependent variable, which is y, because remember, y depends on what x is, so we call this a dependent variable. I'm going to change y to f of x. It's a function of x. It depends on x. 2x plus 2. So now it looks like machine form. So I changed it to function form. That's the first part. And now I'm going to evaluate this function at the input of -8. Remember, inputs are your x values. Watch this now. Wherever I see x, I'm going to replace it with -8. Just like the chickens were the inputs, the chicken McNuggets were the outputs. Here's your input. Let's see what the output is now. Wherever I see x, I'm replacing with -8. Watch. The function at -8 equals 2 times -8 plus 2. Write that down. Right. You should have seen this before. This is math 2. You've seen this before either in pre-algebra or algebra or math 1. Let's keep going. The function now at -8 equals, should you multiply or add first? What do you do first? Right. So it's going to be a -16 plus a 2. So the function, look at I keep writing f at -8. The function at -8 then, or the function at the input of -8 is, what's the output? Well, it's going to be -14. Done. That's it. Is that easy or what? The hardest thing is just getting used to that. Instead of remember when you're a little kid, or maybe in math 1, instead of f of 8 equals -14, you'd write this. Y equals -14. We're not doing y anymore. Y means at the function at that input. It's kind of like a transition you have to make in your mind to a higher level of math. That's the hardest part of today's lesson. It's not that hard. You just got to pay attention. And put your phone down unless you're addicted to it. I'm not going to mention any names. One more example. Last one. Hold up. Write down though. I'm watching you. Let's do it. Change to function form and evaluate at the input of -3. So go ahead and give it to me in function form, Valdez. Sorry, I'll just. Sorry. All right. Give it to me in function form, Valdez. Hit it. Hit it. Save the day. Go ahead. Oh, wait. If not, I'm going to go to Esquivel. He'll save the day. He's got your back. Gonzalez woke up. You're the man. Extra stamps. Oh, he went back. Darn it. Valdez, go ahead. What is it? Save the day. It's Esquivel. Hit it. F of. So wait, let's first do it in its function form. So f of x equals, hit it. -8x minus 2. Okay, so that first move right here is changing it to function form. That's that first part. Okay. Oh, my bad. That's the first part. Now that's where you're headed too, Esquivel. So the input now is not -8, it's -3. Let's go ahead and replace the inputs now. The function at -3, that's like the cow or the pig that we just saw, going into the machine. -8 times -3 minus 2. Rocha, should we multiply or subtract first? Awesome. The function then at -3 is positive 24 minus 2. The function at -3 then is 22. So we did two things. We first changed it to function form. That's the first part. And then we evaluated the function at -3. It became the output of 22. Hold up, Samaniego. Questions on example 2? Beautiful. I didn't feel like answering questions. So here's what we're going to do.